Now, for the ideal gas law, first we have the Boyle's law. Okay. Okay. Now, for the Boyle's law, okay, under the Boyle's law, if the temperature of a given quantity of a gas is held constant, the volume of the gas varies inversely. The volume of the gas varies inversely with the absolute pressure. When you say absolute pressure, if the given is under the atmospheric pressure or pressure gauge, you have to convert it into absolute pressure. Remember that the absolute pressure is equal to the atmospheric pressure plus the pressure gauge. We're going to use the absolute pressure. Absolute pressure. Kaya if the given is the atmospheric, you have to add the if the given is pressure gauge, you have to add the atmospheric pressure. Remember, we have the constant value for the atmospheric pressure. Values for the atmospheric pressure, we have 101.325 kilopascal, 1 atmosphere, 14.7 psi. Psi is pounds per square inch. What else? We have 760, 14.7, 760 millimeter mercury. Then we have okay, 29.92 inch mercury. Okay, therefore, the formula under the Boyle's law, pressure volume is equal to constant. That is what? Absolute pressure and the volume. Okay, therefore, we have P1 V1 is equal to P2 V2. Then, if there's no given volume, instead the given is the specific volume, you can also use that. The pressure times the specific volume equal to pressure 2 times the specific volume 2. Then we have the Charles law. Okay. Under the Charles law, if the pressure on a particular quantity of gas is held constant, then with any change of state, the volume will vary directly as the absolute temperature. We have the volume directly proportional to the temperature, where volume is equal to the constant times the temperature, or V over T equal to capital T. Therefore, the temperature is absolute. If the given is under degree Celsius or degree Fahrenheit, you have to convert it into absolute temperature. Okay, remember that your Kelvin is equal to degree Celsius plus 273, and degree Rankine is equal to degree Fahrenheit plus 460. So that your temperature will become absolute. Kasi if the given is not absolute, you have to convert it into absolute temperature. Okay, therefore, we have the formula under the Charles law. We have V1 over T1 is equal to V2 over T2. Again, all the pressure and temperature under the ideal gas law should be under the absolute. Absolute pressure, absolute temperature. Now, this one is for the Charles law if the pressure is constant. Let's see, pressure is constant. Okay. When you say pressure is constant, your P1 is the same as P2. Okay. Here, the temperature is constant. Your T1 is the same as T2. Next. Okay. Number 2, under the Charles law, we have if the volume of the particular quantity, of the gas is constant. Therefore, your P, which is the absolute pressure, is directly proportional to the temperature, absolute temperature. Or you have P is equal to CT, constant T. Okay, or your absolute pressure over the absolute temperature is equal to constant, or that is P1 over T1 is equal to P2 over T2. Remember, again, the pressure is absolute, the temperature is also absolute. Now for the review of familiar properties. Okay, number one, we have the pressure. Okay, remember that the pressure is the ratio of force and area. But under the thermodynamics, when we say pressure, we're talking about the absolute pressure, the atmospheric pressure, the absolute pressure, and the pressure gauge. Okay. Then we have the temperature. What are the units for the pressure? You have Newton per square meter, Dyne per square centimeter, What else? We have pounds per square inch or pounds per square foot. Okay. Remember that the pounds here is in weight, not in mass. Okay. Or pound force. Okay. Number two, we have the temperature. Okay. Temperature is the hotness or coldness of the body. Temperature is the hotness or coldness of the body. The symbol for the pressure, P. For the temperature, it's either capital T or small letter t. Capital T, indication of the absolute temperature. What are the units? We have degree Celsius, degree Fahrenheit, Kelvin, degree Rankine or degree Rankine. Okay, number three, you have the volume. Okay, symbol, capital V. Okay, what are the units? Cubic meter, cubic centimeter, milliliter, liter, inch cube, cubic foot. Okay, next, we have the specific volume. Specific volume. Okay, the symbol for the specific volume is small letter B. What are the units for the specific volume? We have cubic meter per kilogram, cubic centimeter per gram, cubic inch, cubic foot, slug, cubic foot, pound mass, and so on and so forth. Okay, number five, we have the density. There are two types of density, the mass density and the weight density. Okay. Now for the mass density, the symbol is capital D. For the weight density, the symbol is capital D. Raw mass density. Capital D, weight density. Okay. Then, what are the units? We have kilogram per cubic meter, gram per cubic centimeter, slug per cubic feet, pound mass per cubic foot, and so on. Okay, number six, we have the specific weight. Specific weight. Okay. Now for the specific weight, we have the symbol. What are the units for the specific weight? We have Newton. Newton per watt. Naubos na kayo, ha? Okay. Okay, we have the Newton per cubic meter. What else? Dyne per cubic centimeter. We have pound force per cubic foot. Pound force per cubic inch. Okay. Then we have the mass. Okay. The symbol is small letter m. What are the unit for the mass? We have kilogram, gram, slug, pound, mass. Then number 8, we have the weight. Okay, the symbol for the weight is capital W. We have Newton, kilogram force, gram force, pound force, kilogram, gram force, pound force, dyne. Okay. Then we have the ideal gas. Okay, ideal gases. When you say ideal gases, okay, the concept of an ideal gas can be used as a model for the behavior of real gases. An ideal gas is a gas whose absolute pressure, absolute temperature, and specific volume obey the equation of state. At low pressure and high temperature, gases can often be modeled by the simple equation, the ideal gases of the ideal gas equation of state. We have P V is equal to R T, where R is the specific gas constant, where R is the specific gas constant. Okay. We have the formula for the pressure volume is equal to mass rho. PV is equal to MRT, where R is the specific gas constant. PV. But, okay, we have, from that equation, we can say that your pressure volume over the mass is equal to RT. Okay, pressure volume is equal to RT. Okay, or we have pressure 1 over rho RT. 1 over the density is specific volume. 1 over, volume over the mass is not a density. Wait, sorry. Volume over the mass is specific volume. Specific volume. Okay, specific volume, kaya we have PV is equal to RT. That is the reason we have PV is equal to RT. Volume over the mass is specific volume. Then 1 over the specific volume is density RT. Where R now is the specific gas constant, P is the absolute pressure, V is the specific volume, P absolute pressure. R is the specific, ayan na, R pala. T, absolute temperature. T is the absolute temperature. V is the specific volume. Another formula, your specific gas constant is also equal to the universal gas constant over the molar mass or the molecular weight. Okay. R is the specific gas constant. R bar is the universal gas constant. universal gas constant. And the universal gas constant has a constant value that is 8.3144 kilojoule per kilomole Kelvin, or that is 1.9859 BTU per P-mole degree Rankine, or that is 1,545.3 foot-pound force per P-mole molecule degree Rankine. MW is the molar mass or molecular weight. Then R is the specific gas constant. What are the unit? For the specific gas constant, we have kilojoule per kilogram Kelvin, BTU per pound mass, degree Rankine. Okay, remember that 1 BTU is equal to 778 foot-pound force. Okay, the amount of a substance can also be given in terms of the number of moles. Okay, when you say moles, abbreviation is MOL. The molecular weight of a substance is the number of kilogram per mole of the substance. Okay. Now we have MW is equal to M over N, where M is the mass, N is the number of moles, M is the mass, N is the number of moles, and MW is the molecular weight. Okay, what are the units? We have kilogram per kilomole, pound mass per p-mole. Ang unit of mass, kilogram mass, pound mass. For the number of moles, we have kilomole and p-mole. Now, we have the alternative. Alternative forms of the ideal gas equation of state. We have PV is equal to MRT. Absolute pressure, volume, mass, specific gas constant, temperature. Another formula. We have PV is equal to N times the molecular weight times RT. Okay. And multiply by the molecular weight or molar mass, we have M, the mass is equal to N times MW. Okay. Then we have PV is equal to m r bar T over the molecular weight. PV is equal to mass flow rate times RT. Remember yung M raised to that is mass flow rate. Then we have P is equal to rho RT. PV is equal to NRT. And then we have P specific volume is equal to universal gas constant times T over the molecular weight or the molar mass. Okay, where V is the volume flow rate. Okay, balikan natin. This one is the volume flow rate pala ha. Pressure volume flow rate is equal to mass flow rate RT. Okay, volume flow rate, volume flow, volume flow rate. Then we have M, that is mass flow rate. V is the total volume, capital V, total volume. M is the mass. P is the absolute pressure. T is the absolute temperature. Rho is the density, mass density. Mass density. Then, okay, remember that the unit for the volume flow rate is cubic meter per second, cubic feet per second. Okay, we have kilogram per second, pound mass per second. Okay, volume, of course, you know the unit, cubic meter, cubic feet, cubic centimeter, cubic feet, liter. Okay, mass, kilogram, slug, pound mass. Then for the absolute pressure, kilopascal, PSI, pounds per square inch, absolute, bar, atmosphere. And also torr. Torr is also a unit of pressure. Then we have the temperature, Kelvin, degree Rankine. Okay. For the density, we have kilogram per cubic meter, pound mass per cubic